Hello, hi, good morning to all of you. My name is Mio Ikram from UKM. Today I would like to present about the predictive modeling of crypt-crack initiation and growth using XFEM. Okay, this is the quick overview about my presentations. Starting from introduction, numerical framework, results and discussion, conclusion, at last as an acknowledgement. Okay, for the introduction, the CT integral is used to characterize the crypt fracture initiation. Meanwhile, for the XFEM is employed to spot located inside the finite element for the purpose of predicting a crack potential and propagation. So this study is we are focused on the crypt crack growth when the crypt initiation is represented by the CT integral, and the XFEM is used to represent the crack propagation and growth. Okay, the second one, the CT describe the intensity of the near tip field in the elastic non-linear viscous material. Just a quick introduction about the XFEM. XFEM introduced a numerical model of the crack initiation and propagation in which the approximation for a displacement vector function with the partition of the unity enrichment. Okay. Okay, this is the flowchart, the overall flowchart for the XFEM that we use in this study. Yeah. Okay, for the numerical framework, just a general form in order to find the value of the CT integral using the line integral. When you look at here, when the CT is calculated based on the value for the strain energy rate density, and also how the XFEM is calculated based on the discontinuous displacement approximation on the crack propagation of plane problem. Okay, next we go to the results and discussion. At last, as a result, we divide the results into a two section, which is the first is the rectangular plate with the single crack. As can you see from here, the graph of the CT integral versus time. Okay, and then the results of the simulation we compared with the analytical solution from the previous researchers, and we can see that the results is reasonable to compare, yeah, with respect to the CT integral with time. Okay, next we shown the contour of the rectangular plate for the contour stress, and also magnitude of the displacement, so with the crack initiation together with the propagation of the crack. Then we go to the second one, which is the compact tension specimens. Here we come out with the two graphs. For the first graph in the above one, this is a crypt crack growth delta A versus the normalized time, and then we compare with the experimental data from the previous researcher, and we can see that the patterns appear quite similar with each other. And last one, the bottom one is the crypt crack growth dAdt versus the CT integral. We compare with the result from the experimental and shown the appear similar relationship between both results, with the R square value closer to 1. Okay, so this is the contour plot for the CT specimen with respect to the stress and also for the magnitude of the displacement. Therefore, in conclusion, the CT integral and XFEM formulation relationship had facilitated in predicting the ductile materials crypt crack initiation and crypt crack growth behavior, and subsequently verified the results of the study. The next analysis regarding the crypt material behavior will be conducted by representing the damage parameter of a crypt failure. I think that's all for my for my slide. I would like to express my gratitude to the UKM and the research GGPM 2019-059 for supporting this research project. Thank you so much to all.